All right, in this video, we're going to work through the following problem. It says solve the triangle, and we are given that angle A is 35 degrees, side A is 12 units, and side C is 17 units. And I've labeled it as a side-side angle example, we know it's side-side angle, but let's just say what would you do if you didn't know that, if you weren't aware of that, like you might be on the homework. I don't know if they're going to give that to you or not. So what you would have to do, right, is just draw the triangle. Let me start over. And label the angles A, B, and C, and the side opposite those in the correct way, right? So that side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. And then label what you know. We know that A is 35 degrees. We know that A is 12. And C is 17. Okay, so that's what the picture looks like, and from there we can see we're given two sides and an angle, and we're given sides A and C, and we can see that angle B is not given, right? That would be the included angle, the angle in between those sides, and so we're definitely in the side angle case here. All right, so what we want to do is to solve for one of the sides opposite, and we're going to have to solve for C here, right? We already know that angle A and the side opposite 12, right? So we're going to have to solve for sine C. So we're going to have sine of angle C divided by C is equal to sine of angle A divided by side A. And we know those values, right? We know that, well, we don't know the angle C, but we do know that side C is 17. And we know that angle A is 35 degrees. We know that side A is 12 units. All right, so we'd cross multiply. We'd multiply 12 times sine C. And cross multiply here, 17 times sine 35 degrees, and then divide both sides by 12. So we get sine C equals 17 sine of 35 degrees divided by 12. All right, and we want angle C, right? So what we would do is take the inverse sine of both sides. That would leave me with just C, right, over here on this side, and I'd have the inverse sine of 17 sine of 35 degrees all over 12. Like so. All right, so we would go to the calculator. Making sure that we are in degree mode. And I get that C is approximately 54.35 to 2 decimal places. Okay. All right. So we have angle C, right? And so looking at our procedure that we're using for the law of sines, right? We got solve for sine C. We use the inverse sine function on the calculator to get an approximation of the angle. We didn't get an error, and we didn't get that the angle was 90 degrees. And so what we would do is move on to step 3, and we would split it into 2 cases, right? So case 1 is that angle C is 54.35. Okay, and then case 2 is that angle C is 180 degrees minus 54.35 degrees. Okay. And so that comes out to be 180 minus 54.35. So 125.65 degrees. Okay. All right. So those are the 2 possibilities that we have. All right. Next up, what we would do in each case is to calculate the missing angle, which is angle B, right? So angle B in case 1 would be 180 minus angle A minus angle C. And remember, this case 1, right, is always going to give you a solution if you've gotten this far, okay? So that's 180 minus 35, and so we get 90.65 degrees, okay? All right, and we're going to do the same thing here, right, in case 2. In case 2, B would be 180 minus 30 angle A, which is 35 degrees, minus angle C, which is 125.65 degrees. All right, and so in this case, we're going to get 19.35 degrees. Okay. All right, and you can see in case 2, this led to a perfectly legitimate value, right? Sometimes, if you watch the previous video and the previous example, case 2 led to a negative value for angle, for whatever angle it was, and so that's when you know that case 2 does not lead to a triangle. In this case, we have perfectly legitimate angles, right, for each of these, and so we know now at this point there are 2 triangles. Okay. Okay, and so what we would do in each case is to solve for that last side that we don't know, which is angle B. All right, so we would have to do it twice, right? Once for case 1, once for case 2. So we're after B, side B, right? So it would be sine B over, or sine of angle B over side B. And again, I like to use the side angle pair that I'm given. So that's sine A over side A. Okay. All right, and so I get sine of 90.65 degrees over B, which I don't know. And the sine of A would be 35 degrees. Over side A, which is 12. All right, cross multiply, I get B times the sine of 35 degrees equals 12 times the sine of 90.65 degrees. And so B would be equal to 12 sine of 90.65 degrees divided by the sine of 35 degrees. All right, and go to the calculator. So 12 sine 90.65 degrees divided by sine of 35 degrees. And so I get B is approximately 20.92 units in this case here. All right, and then I'm going to have to do exactly the same thing for case 2, right? Using the same formula here, sine B over B, right? So that's going to be sine of angle B. Angle B in this case is 19.35 degrees over B. And sine A, right, over A. So A is 35 degrees. And side A is 12. All right, and then I'd solve exactly like I did here before, right? I'd wind up with cross multiplying, right, and then dividing by sine of 35, exactly these same steps over here. I would wind up with B equals 12 sine of 19.35 degrees over sine of 35 degrees. So it's exactly the same work as it is over here. The only difference is you're using a different value, right, for this angle, B in this case, over here. All right, and so now again to the calculator. And angle B would be approximately 6.93 units, and that's the 2 decimal places. All right, and that is it on this one.